Next crucial step is the foam penetrates deep into micro cracks and surface imperfections. After inspection and repair for proper restoration and repainting, the foam penetrates its deep hair cracks and superficial road. In service from the aircraft sirens, each manual pass restore working surface. Rivet lines are critical structural components of the aircraft. Even small dirt particles trapped inside can affect corrosion protection and inspection accuracy. After deep washing and detailed cleaning, with the surface fully dried, the aircraft is now ready for deeper mechanical recurrence. Long-term exposure to humidity can cause biological growth on aircraft surfaces. Removing it carefully protects the metal from corrosion. Removing the canopy allows full access to the cockpit structure. With the canopy removed, the still a detailed restoration team. Restoration of those flags trigger. Remaining of the reference and team cox removed with the seat. Instrument gauges are the aircraft's communication system with the pilot. Removing and restoring them ensures accuracy, functionality to ensure precision and reliability. The electrical wiring system is critical for instrument operation and aircraft functionality. The electrical suspension. Removing floor panels reveals the aircraft's internal structure. Control removed. The aircraft's internal foundation is now ready for deeper repair. Rust inside structural components weakens long-term durability. Care crushed to inclined feature for long preservation. Sanding removes micro imperfections, preparing the metal for proper coating adhesion. With sanding complete, the surface is ready for primer. Applying a chemical filler to less coated against future's long-term corrosion resistance. Even minor dents affect aerodynamic smoothness. Careful tapping and reshaping restores the metal to its original contour. Rivets play a critical role in maintaining structural strength. Rivets and air for long-term service. Assembly cows and so many stabilizers for wear, but each probably power of the B. Rivets play a critical role in maintaining structural strength. Replacing damaged or rivets or missing rivets, the entire wheel hub assembly must be inspected and fully dismantled. With the replacement complete, the wheel hub is restored to handle extreme stress. Hydraulic systems control landing gear movement. Old fluid must be completely system flushed and restored. Reliable pressure control is reestablished. Proper wing alignment ensures aerodynamic stability and structural integrity. Even minor deviations can affect final fleet. The aircraft regains its structural symmetry. The entire wheel hub assembly must be inspected and fully dismantled. With precision bearing replacement complete, the wheel hub is restored. For all reassembly, it must be cleaning. With cleaning complete, the engine is prepared for inspection. The entire wheel hub assembly must be inspected and fully dismantled. Bearings that show wear must be replaced. Removing the cylinder head allows technicians to inspect pistons, valves, and internal combustion chambers for wear, damage, and structural integrity. Pistons endure extreme pressure and high temperatures. Cleaning carbon buildup restores smooth movement and improves combustion efficiency. The crankshaft converts piston movement into rotational power. Any surface imperfections can create friction and reduce heat, make precision polishing essential. Engine valves regulate airflow and combustion. With cleaning and lubrication complete, the valves are restored for reliable performance. Gaskets create airtight and oil-tight seals between engine components. Proper placement ensures compression efficiency and prevents fluid leaks. Reinstalling the cylinder head restores the sealed combustion chamber. Proper alignment and controlled torque application. The carburetor controls the mixture of fuel and air. Contaminants can disrupt engine performance. The fuel delivery system is now ready for precise mixture control. Fuel lines transport aviation fuel from the tank to the carburetor. Replacing worn lines for tested a new fuel line for safe and reliable operation. The cooling system regulates engine temperature. Old contaminated coolant must be completely removed to prevent overheating, corrosion, or thermal testing. The instrument requires a heat reserve protects metal surfaces from corrosion, heat damage, and environmental exposure. The cooling system regulates engine temperature. Old contaminated coolant must be completely removed to prevent overheating and corrosion. Propeller blades convert in balanced mounting interthrustral. With all blades installed in balance, the propeller is ready for controlled thrust. The cooling system regulates engine temperature. Old consistent flush decolloage, the engine is now protected against overheating. Before engine ignition, a manual rotation test confirms internal component alignment, lubrication flow, and mechanical freedom without obstructing. Proper lubrication is essential before engine startup. Filling the oil system ensures internal components are protected from friction and excessive heat. Before final polishing, the airframe undergoes meticulous sanding to ensure surface adhesion. With the aircraft is prepared for final detailing, surface contaminants must be removed for strong adhesion. With final surface preparation complete, the aircraft is ready for protective finishing. Primer forms the foundation of the final paint system. It improves adhesion, prevents smooth, protected exits. Clear coat seals the paint, enhancing durability and creating seat. The cured finish is durable and high restoration. Historical markings define the aircraft's identity. With historical markings applied, the aircraft's identity is restored. Squadron codes and tail markings define the aircraft's operational identity. Precision application ensures authenticity. With tail identification completed, the aircraft now carries its full historical markings. The final protective clear coat seals the paint and markings, enhancing durability while preserving the visual identity for years to come. Ensure accurate readings and safe aircraft operation. With instruments and tested, the cockpit is safe air fully functional. The cockpit is installed and systems tested, cockpit shore evaporators and sea air apparition, preparing the aircraft for final system integration. Before engine ignition, the aircraft's electrical system must be powered and tested to ensure proper distribution. After successful engine testing, the aircraft undergoes taxi testing. Diversified taxi test confirms full ground mobility and readiness. Before first flight, a comprehensive inspection ensures every system functions correctly.
Exterior confirmed leaks.
After complete restoration, the ultimate moment arrives. The aircraft lifts off for its first flight. After successful takeoff, the aircraft undergoes controlled aerial maneuvers to evaluate stability, control response. After flight testing, the aircraft returns for a controlled landing to verify system performance.
Tower, gear down, flap set.
Checking for oil leaks and cracks on the wing. Control surfaces are smooth. The aircraft passes. After successful flight testing, the project enters its final stage into a fully operational masterpiece. After countless hours of engineering, restoration, the airframe needed deep repairs, but the engine was the biggest challenge after decades of rebuild. Every restoration begins with decay and ends with precision. This comparison shows the journey from neglect to operational excellence.
Beyond visual restoration, the project required structural engineering analysis, mechanical calibration, and system verification to ensure operational safety.
The restoration required structural analysis, mechanical calibration, and system verification for safety. Electrical systems were tested for stability. Aircraft must withstand extreme environmental conditions. Weather resistance testing ensures durability under stress. A true restoration is not complete without verifying emergency response systems.
Power detection test complete.
After structural verification, environmental testing, and emergency system validation, the aircraft now undergoes final airworthiness inspection. After months of restoration, she returns to the sky.
Runway takeoff.
History lives when it flies.
Today it flies not for war, but for remembrance.
The flight lasted minutes, the restoration took months, the history spans decades, but in that moment, everything aligned.
Restoration gives history a second life.
Preserving the style keep it fresh. The scale also with its power.
Restoration is not about machines alone. It is patience. It is precision. It is long. What was once worn by time has been returned to the sky. Not as a weapon, but as a reminder. Every restoration ends with a beginning, because history does not live in one machine alone. There is always another story waiting. One restoration is not the end, it is the foundation. With experience gained, new projects begin, and the next chapter begins now. While preserving historical authenticity, modern safety systems can be integrated discreetly to enhance reliability and operational monitoring. Evaluating engine tension, the LPKD fuel consumption, and system endurance. After successful restoration for the public, alleging flying again. Beyond restoration, this project stands as a symbol of dedication to preserving aircraft. This is a great honor. Aircraft are now flying correctly in the sky and proceeding to our mission.